When you start learning about chemistry, you learn that all matter in the universe can be broken up into two different categories: pure substances and mixtures. Now, we've spent a lot of time already talking about pure substances, which include atoms and compounds and elements and things like that. Now, let's switch gears a little bit and talk about mixtures. Mixtures are basically a bunch of pure substances that are combined together in some way. Basically, they're mixed together, and that's why they're called mixtures. Now, there are two major types of mixtures. You have what we call heterogeneous mixtures and homogeneous mixtures. A heterogeneous mixture is something that is not the same throughout. So a really good example of heterogeneous mixture would be like a chocolate chip cookie. When you have a chocolate chip cookie, there's chocolate chips kind of uniformly spread throughout, but not every single chocolate chip cookie is exactly the same. Or if you take a chocolate chip cookie and divide it in half, each half isn't going to have the same number of chocolate chip. So that would be what we would call a heterogeneous mixture. Another example would be something like trail mix, would be a heterogeneous mixture. The other type of mixture is a homogeneous mixture. Now, another name for a homogeneous mixture is a solution. And so a solution is the same throughout. And it means that it doesn't matter how it's divided, you're always going to have the same characteristics, the same ratio of components. Now, a solution is composed of two things. It's composed of the thing that's doing the dissolving and what is being dissolved. And so in chemistry, most common solutions are made out of water. And so water is what's doing the dissolving. And so we call that the solvent. The solvent is the material or the thing that is always dissolving something else. And it's usually the substance that is in greater quantity. Now, the other part of a solution is a solute, and that is what's being dissolved. So you have a solute, what's being dissolved, and the solvent, which is what's doing the dissolving. So an example of a solution would be tea, would be a good example. So if you have some tea, it has water, that would be your solvent, and then the tea itself would be the solute. Now, if you put some milk or some sugar or something like that into your tea, then that would also be solute. So solutions can have more than one solute. It can have multiple different solutes. Now, another type of mixture that is kind of a type of heterogeneous mixture is what we call a suspension. A suspension is where you have a mixture where there's particles that are kind of floating throughout. And over time, that suspension may eventually separate. Now, not all suspensions will separate, but a suspension is where you have a heterogeneous mixture where the particles are suspended throughout. And usually you can see those particles. Now, if you have a suspension where the particles don't separate, so an example would be, let's say you have some oil and vinegar or some vinaigrette dressing. And if you shake it up, you're mixing up those oil particles and all the spices and things like that. And for that particular amount of time, it is what we would call a suspension. It's a heterogeneous mixture. And then if you let it sit out for a little while, it will gradually separate out. So a suspension will some suspensions will gradually separate out, where all the particles are initially floating around and then they gradually settle to the bottom. Now, if those particles stay suspended throughout, then we have what we call a colloidal suspension, or just simply a colloid. A colloid is where the particles are uniform throughout. You can still kind of see them, and but they won't separate. They kind of stay suspended in the solution. That's why we use the term suspension. Now, whenever you're making a solution, remember, a solution is made of a solute and a solvent. So there's always something being dissolved. And so that process of dissolving is what we call solubility. Solubility is a property that substances have whether or not they can dissolve in a medium of some sort. Now, in chemistry, we usually use water as our solvent. And so a lot of times when we're talking about solubility, it's all about the solubility in water. And There are two types of particles or two types of compounds that we've talked about this semester, and that is whether or not a compound is an ionic compound or a molecular compound. Now, if it's an ionic compound, then we have to follow the solubility rules as to whether or not it dissolves in water. And so you might remember the solubility rules that, for example, all nitrates are soluble, any ionic compound that has the ammonium ion is soluble, all the halides, so if there's a chloride, iodide, or bromide, then it's soluble in water with the exception of the silver, mercury, and lead ions. So if you don't remember that, do a search on solubility rules and you can kind of see a table or some examples of things that are not soluble. And so if it's an ionic compound, then we follow those solubility rules. The other type of compound that we talked about was a molecular compound. And so determining whether a molecular compound is soluble, we have to look at the polarity of that molecule. And so the polarity, remember, is dependent on the structure of the actual compound itself. So if there's a positive end and a negative end, depending on how the electrons are oriented, then it's what we call a polar molecule. And a polar molecule will always dissolve in a polar solvent. And so water is a polar solvent, so water will dissolve polar compounds. If it's a nonpolar compound, then it will only dissolve a nonpolar solvent. So this is the reason why oil and water doesn't mix. Oil is a molecular compound and it is very nonpolar. Water is also a molecular compound and it is polar. And so water being polar, oil being nonpolar means they will not mix. And so the polarities of the solute and the solvent have to match for it to dissolve and intermingle. A lot of times we use the phrase like dissolves like. And what that means is that if the polarities are the same, then it will dissolve. Now, when an ionic compound does dissolve in liquid, in water, what happens is the ions separate out and then the water molecules surround those ions. That process of surrounding the ions, those water molecules surrounding the ions, is what we call hydration. Hydration is where we have the polar molecule, water molecules, surround the extremely polar ions. And so it just kind of surrounds and encapsulates those ions, and that's what causes the dissolution process. Now, when ionic compounds do dissolve, we can have two different things that can happen. They can get hot or cold depending on whether it's an endothermic or exothermic reaction. If it's an endothermic process, and that means heat is going into it. Well, where is that heat coming from? It's coming from the environment. And so if it's an endothermic process, it feels like that solution is getting cold because it's bringing in heat, it's taking heat in from the environment. Now, an endothermic dissolution would be an example of like a cold pack. When you have a cold pack and you break the little cylinders inside to release the water, there's always a solid in there. That solid dissolves and it gets really cold. That is what we call an endothermic process. The other type is where heat escapes, and now we call that an exothermic process. And so an example would be a hot pack, where as the dissolution happens, it gets really hot. And so whenever hydration happens, whenever we dissolve an ionic compound in water, it may either be an exothermic or an endothermic process. One thing that can help things dissolve is temperature. So normally we think that as we add heat to water, it can dissolve things easily. And for the most part, that is always true. However, there are some substances that when you heat it up, the solubility, the ability for it to dissolve, actually decreases. So temperature does affect the solubility, and it just really depends on what the compound is as to whether heating it up or cooling it off causes it to dissolve more. Now, for gases, there's a slightly different take on it. For a gas, whenever you heat up the solvent, gases will not dissolve easily. So for a gas to dissolve in water, you really want a cold water solution for the gases dissolve in. And so the colder the water, the more gases that will dissolve. And this is why, for example, your sodas get flat, meaning they have no more carbon dioxide in them during the summertime, or if you leave them in a hot car. That's because the carbon dioxide doesn't stay, is not soluble in the water anymore at higher temperature. Now, another thing that can affect the solubility of gases is pressure. And so if you increase the pressure, then that means you're pushing those gases into that liquid, and so the solubility will actually decrease as pressure increases. So temperature plays a role as to how things dissolve, as well as pressure.